All right, everybody. Sorry for the delay there for a second. We'll get started here right now. So you should be able to see my screen there. So we got a webinar today that's understanding stone wool insulation in interior and exterior applications. My name is Randy Plumley. I will not be your presenter today. We actually have Nick Stone from Rockwool, which will be, he's joined us now, and he'll start in just a second. Nick, just give me a minute. I'm going to do some housekeeping.
Absolutely.
So as always, this webinar is being recorded. It will be available afterwards on YouTube, probably within about 72 hours. You can find our channel on by searching Spear on YouTube. You can also go to our website at eepartnership.org. On the homepage, you'll find the news section. Under that, you'll find resources page, and you can go directly to our YouTube channel. Of course, right now we have over 150 videos covering a wide range of energy code and HVAC topics. So today's session is eligible for the ICC CEUs. To receive that, you'll have to be present for at least 3/4 of the presentation. Within about 72 hours, Kathy Lawrence will send you a brief course evaluation. If you guys have done it here before, you know how this rolls. Please complete and return the survey. I appreciate all the feedback that I've gotten from previous webinars. It really does help me fine tune and get better. I did see a lot of feedback from the last one, and we'll try to get some more technical information for you on the refrigerants that we did a few weeks ago. The chat feature is going to be open. I'll monitor that. Nick, you can just tell me whether or not you want to go through questions as they come through, or wait till the end.
Okay.
And then I'll
Yeah.
also have the Q&A feature open. Go ahead. What?
Yeah, I mean, if you want to jump in as we go, I think that's totally appropriate, especially as we're on, certain topics.
All right, and if you're new to this, you're wondering who is Spear, what do we do? Thanks again for joining us. We are one of the 6 regional energy efficiency organizations known as RIOs. We offer free training, webinars, in-person sessions, as well as field support. I can also help with IECC certification test preps. If you have any questions about the energy code, ASHRAE 90.1, whether you're plan reviewer, building official, third-party energy inspector, I'm happy to help. That's what I'm here for. So we've got quite a few cities that we're also helping with the adoption of the 21 and now reviewing the 24. We can help you guys understand the amendments that other cities are doing and looking at and proposing to see what best fit for your city. So as always, I'll share my contact information at the end of this presentation. So feel free to reach out to me and share my information with anybody that you think I can help with on answering codes to the energy code. So Nick, that's my housekeeping, and I will stop sharing my screen if you want to just start with yours.
Yeah, absolutely.
And thanks for being here. I appreciate it.
All right, well, I'll go ahead and jump right into it. My name is Nick Stone. I am the residential architectural specialist for the U.S. I'm based in Vermont. I've been working pretty heavily in the building science, exterior insulation packages for about the last 15 years now. And Vermont is certainly one of the more progressive areas. For instance, we are now required by code to have exterior insulation on all buildings, whether it's renovation, new construction. So we really kind of have that deeper energy side of things. Like I said, I do cover the country, working with architects, custom home builders, primarily on design. And, when you move to what I call a two-dimensional wall to a three-dimensional wall, where you add depth, you add exterior insulation, that's really where a lot of my expertise kind of comes into play. We do have my other partner, Omar, on as well. I'm not sure if he's able to unmute or not.
Hey everyone, my name's Omar Cantu. I'm based in Austin, Texas, and I am the business development manager for Rockwool for the South Central region. My role is basically to support you guys, support architects, custom home builders with anything and everything they need for in order to build better, right, in Texas. So if there's anything you guys need, please let me know.
Absolutely. We're excited to have you on. So today we're going to be going through understanding stone wool insulation with a focus on exterior insulation and rain screen applications. Some of these slides you'll find that I kind of breeze through. the big reason for that is I'm trying to get through get to some of these details at the end, some of the building science, some of the stuff that I think from a day-to-day perspective, you will find quite interesting. Big picture speaking, 40% of all CO2 emissions are coming from buildings. So one of the big goals by AIA 230 is to reach carbon neutrality. A couple of different ways we think about this is we think about it from, using more efficient installations, the way we're sequencing installations, for instance, instead of just having cavity insulation. Now let's start to take a look at using split insulation packages where we have insulation on the outside of the wall, insulation on their cavity, taking these systems and making them more and more efficient. I know that a lot of what you guys are building is perhaps in the zone 1 to 3 category, where heating isn't necessarily your number one concern, but certainly cooling is something that you're thinking of, air quality, and all those things. So having systems that are performing well, not only just year one, but a decade, 2 decades, 3 decades down the road will be extremely important for the efficiency of these buildings. Omar, you want to jump in on a few of these?
Sure. So essentially, there are two different types of insulation types. They kind of are categorized between fibrous or vapor open, and then foam plastic or vapor closed. So within the vapor opens category, we've got fiberglass, stone wool, slag wool, cellulose. And then within the vapor closed, we would have like XPS, EPS, ISO, and SPUF.
Now, this will play a bigger role when we get into the building science, as far as vapor flows, looking at exterior insulations. This idea of vapor open versus vapor closed will become, as we get to the second half of this, a bigger talking point. But first, we're going to kind of go through what is stone wool. So, Omar, what is stone wool?
Yeah, so stone wool is basically just that. It is made from rock. Essentially, it is made from recycled and natural materials. It's produced from natural and abundant basalt rock and recycled slag, which is a byproduct from the steel manufacturing industry. The wool is essentially spun, blown, and compressed into variable forms, including bat, board, pipe insulation. Essentially, what we do is we take basalt, the basalt mineral, we superheat it to over 2,000 degrees. And we put it in essentially a giant cotton candy machine. Obviously it's going to melt down, create essentially lava. As it spins, those fibers are going to start to cool. Then they're collected, compressed into the various products, and put through a mineral oil based binder bath, essentially, and which gives it the water resistant properties that it has.
Yeah, it's a binder, not a petroleum binder. So that mineral binder is what's going to give it its great water resistant capabilities, but still allows it to be fire resistant. That's essentially, no matter whether you're board or you're a bat product, it's the same exact materials compressed to different densities for different applications. One thing I just want to point out real quick, basalt is quickly becoming our number one, our biggest amount of product within our material itself. We're kind of moving away from the slag category. The stone fibers produce just a little bit better, more consistent bat material, and allows us to have a little bit higher heat resilience than our slag material can hold up to. So we're starting to kind of shift away from some of that. Looking at the environmental sustainability side of things, Omar, why don't you run us through the different characteristics from environmental standpoint? This is kind of a brief overview. This is an AIA within itself, but just kind of touching on the high points here.
Yeah, so this is probably, Nick, this is actually probably one of my favorite ones, one of my favorite slides, because it talks about how environmentally friendly stone wool is. It's a natural and renewable resource. It does not off gas into the environment, which is a really big deal, especially to the spear group. It does not promote growth or mold or mildew of any kind. It's a zero waste to landfill product, meaning that essentially after its life inside the walls, it can actually essentially be recycled and remade again, essentially. And the water from our production process is collected and is reused, so it's automatically put right back into the system. Stormwater is collected for use in our own production. Recycled heat from our processes also is used to augment the heating process. And Rockwool insulation saves 128 times the amount of energy used to produce the product over a 50-year span. It's made from between 16 to 40% recycled content, and BAT products are Green Guard Gold certified, and we do have all the LEED documentation available if you need that documentation for a LEED certified build.
One thing I always like to say here in this kind of this part of this environmental portion of it is oftentimes people think of, we're melting stone down, so it consumes a huge amount of energy to do so, and which it does. But one thing that we're really taking a hard stance on, as far as from a company standpoint, is we are really trying to figure out each and every year, how do we make better melting technology? How do we make ourselves more and more efficient compared to where we were 10 years ago? We're leaps and bounds ahead of where we used to be. All of our factories in North America are running either hydroelectric or natural gas. So we've gotten away from a lot of the dirty fuels, and we're constantly just working on new technology in that melting part of our system. So something that we find we're very excited for, and something that we hold super dear, constantly lowering our impact from an environmental standpoint. Now, we do have factories all around the world. Omar, which factories that we have here in North America?
We got West Virginia and Mississippi, and we are actually we have one that's in the process of being built over in Washington as well.
And we also have two in Canada. So Grand Forks, British Columbia, and Milton, Ontario. So we have 5 in North America and many around the world as well. This is a little bit of an older slide. We have over 30 factories now around the world. But we're super excited to finally get one on the West Coast, which, believe it or not, for you folks down in Texas, is actually going to free up a huge amount from that Mississippi plant, making sure we're getting constant flow, getting more material, whether it's BAT or board product. So we're super excited to be able to have that offering to really supply your great market. Now we're going to move into the solutions, where all of our materials located around the building, to give you kind of a bird's eye view of where can you use Rockwool, what does that look like. For this slide in particular, we are going to be specific to our product, just so you can get an understanding of where it's all located. Omar, why don't you walk us through that part of things?
Yeah, so where can you use stone wool? Essentially everywhere. Every part of your build, there's a way that you can insulate it using stone wool, using the 3 primary residential products. Up in your attic space, you can use the thermal bat insulation. That can also be used on the inside of your exterior walls, or for like a party wall insulation kind of assembly. It's great for fire and soundproofing, so it's great for in between floors, so that way you don't hear the stomping of feet and things like that, or the rumbling of a subwoofer. In terms of it's not so much that important in the Texas market, but it can also be used for below grade. So you can do it between under your foundation, things like that. And it's also great for continuous exterior insulation, which is important for fire resistance, especially in WUI zones, which we'll get to.
Yeah, so for our sound product, we have a Safe and Sound, which is offered in a 3-inch or 6-inch product. So 3-inch for your interior walls, 6-inch for your floor assemblies. This is going to be offered in 16 or 24 inches on center. We move to our Comfort Bat, which is our exterior wall. That's offered in a 2x4. 2x6, 2x8, and 2x10. So for those options from the 2x4, we have an R13 and an R15. For 2x6, we have an R21 and an R23. For a 2x8, which is really moving into your kind of roof assemblies or overhang areas and things like that, that's going to move into your R30. And then your 2x10, now you're offering an R38. So whether, like I said, whether you're in that roof line, cantilevered overhang, or you just have a thicker, maybe passive house style build, we have some different offerings for all those different thicknesses. For the comfort board material, what you see here on the outside of the building, that's offered in 1-inch all the way up to 5 inches, essentially in half-inch increments. So depending upon what you're trying to achieve for an R value, if you're trying to do the perfect wall where we're getting our interior ratio to cavity ratio to exterior ratio to the correct point where our condensation always forms on the outside of our WRB. If you're looking for that ratio, those different thicknesses will kind of help you ebb and flow to get those different designs. So no matter where you are, just to kind of recap, we do have solutions from board to bat, from roof to walls to below grade. And we're super excited because a handful of years ago, we didn't have all these offerings, but we finally have them to really maximize all the different areas around the building.
Nick?
So now I'm moving into our features and benefits, starting
Uh,
off with
Go ahead, Randy. Did you have a question?
Sorry, yeah, on that last slide, just one quick thing. I know you, and never mind, you're going to get to it. I was going to say, can you speak more to the fire ratings or the resistance to that? And it looks like you're heading that direction, so my apologies.
Yeah, absolutely. So starting off with our fire resiliency, this is certainly something that's, really becoming more and more popular, especially with all the fires that we've had on the, out west as of late. But when we start thinking about fire resiliency and design of the building, I like to refer to it as an equation. So when we start to think about our equation of wall or roof design, it's really important that we start to think about adding non-combustible materials into this equation so that way if we do have some issue with a wildfire or Texas, being that you guys are just so close to one another. So if what happens if your neighbor's house catches on fire? Well, having some kind of non-combustible, resilient material within that equation really starts to play a larger role in how we think about building and designs today than maybe we did 50 years ago. So one of the big ways, because of some of these fires, that we've really started to take a look at these products is this ASTM E84 test. Now, within this test, basically it's a 25-foot chamber. There's insulation that gets laid on the bottom of this chamber, and a torch gets applied to one side. We then get to see how far the flame will travel and how much smoke gets developed in the air. Now, when it comes to fire, the important thing to note here, it's actually the smoke development that is the deadly part of the equation. It's not necessarily the heat itself. So when we look at this ASTM E84 test, we notice we have a zero of flame spread and we have a zero smoke development. If you've ever seen us at a show, we always have a torch applied to one of our products, just to show that resiliency of our material. At the end of the day, we are just rock. So that's what that non-combustible material to help us so we can meet these requirements. You look at fiberglass, cellulose, they're somewhere in the middle of that 25-foot chamber and that smoke development of about 50 parts per million. But this is really where that whole focus starts to shift. And I know a lot of folks down in your region kind of like to spray foam idea, but when it comes to fire protection, this is something to really kind of consider and think about. They do max the machine out of 25 feet, so that full 25-foot chamber does have a flame spread and has a smoke development of 350 to 450 parts per million. So it's substantially more than the other installations that are listed here. And then we start to take a look at their melting temperatures, and this is real. Broken down by the ASTM E119 test, which you'll see a lot in the WUI applications and amber tests and things like that. But your foams of the world, they're going to have a melting temperature of about 400 degrees or less. Your fiberglasses, they do a little bit better, around 1100 degrees. And then you can see where the stone fibers really set themselves in a completely different standard. Now, in the stone fibers, we can withstand temperatures of over 2000 degrees over several hours before anything will happen to our product. Um, Now, I'm a big believer in, all these tests are cool and great, but what's it mean in practice? Like, what does it mean for us builders, us designers? What does that actually look like? Well, I was on a project up in Maine where they had the roof line insulated half with fiberglass and half with rock wool. And when I walked up the stairs and I looked up into the rafter bays, I could tell the exact bay where it went from fiberglass to our product because it was charcoal plywood and then beautiful blonde plywood again up in that roof assembly. So for me, that was a big, oh, okay, that's the fire protection that we're talking about in practice, instead of just, these hypotheticals. Now, to give you an example of kind of what that would look like, here's a video of us doing a test where we have XPS on the outside of our building. We're going to have stone fibers, stone wool on the outside of the bottom one. At about 3 minutes, we'll pay attention to this upper right-hand picture here and how fast once that heat, energy, flames gets up into that attic space, how quickly it can take over. At about a minute 30, we'll watch this upper left picture and just see that smoke that we're really talking about. And also something to point out is the top is relatively normal speed where the bottom is sped up.
And this would be to essentially simulate, a grill fire or something, uh, you know, gets pushed up against
or
the
even a
outside of the
wild
home.
or even a wildfire or your neighbor's house being in proximity too close to yours.
And those embers get close to that other house. Yeah.
And you can see right now at around 2 minutes how thick that black smoke really is.
And that's the stuff that incapacitates you and you get trapped inside that building. So that black smoke is starting to billow into the attic area. And we're about to have flashpoint. Yep, there it goes. So as that one flashed over right around 3 minutes, the stone wool is still ticking. And I think we cut off the camera at around 30.
And you can just see how nice that material still looks. The soot is just from the incomplete combustion of the fuel they're using, but the rock wool itself the stone wool itself is completely unharmed. So when it comes to fire protection, having a non-combustible material within that design really plays a pretty pivotal role in keeping these buildings safe and durable. So now we're going to move on to Omar's favorite category, sound absorption.
Yeah, so this is one of the things that I love as well. Because as you know, a lot of homes out there, they're being built with these great open floor plans, these super tall cathedral ceilings, and it looks gorgeous, but it is loud. And if you've ever lived in a home that has that type of floor plan, you know that you can hear the kids from every part of the house, right? So everything seems to be getting louder. We have these open concepts, and of course, noise has without those divider walls, noise travels a lot further in these types of home builds. Appliances are always running. Plastic pipes are in the home that vibrate. We got the kids in the other room playing video games. Television is all the way up, and it's crazy. So one of the things that is important is being able to mitigate that sound. So you can put stone wool insulation in the walls and on the floors. What that does is it adds density and mass to the walls, so it doesn't allow those sound vibrations and the sound frequency. It slows it all down, so it becomes a little harder to hear. Also with soft finishes and also soundboards. The bottom right hand corner, I actually have some right now, right in front of me in my office. It really cuts down and absorbs those heavy frequencies.
Another thing to kind of point out here is when it comes to density of material, this is one of the critical factors. Your average fiberglass is right around 1.2 to 1.4 pounds of density, where our sound material is actually 2.5 pounds of density. So with that extra density, as you can imagine, that way. I'm trying to figure out where this camera is in reference to my hand, but as that sound wave travels through the air like this and it hits that denser mat, well, that denser mass what's going to slow down that transfer of vibration of that sound from one location to the other. The other part of it is disconnect. So our bats are 3 inches thick instead of being a full 3.5. So by that half-inch disconnect, that vibration factor is going to help stop from one side to the other. So the combination of the two of them plays a pretty big role. Now, when it comes to sound, not everything is created equal. So when we're just talking or simple noises like this, that insulation does a pretty good job. But what happens, Omar, when you start banging stuff around, moving stuff, you kind of enter a different part of the sound frequency.
Vibration.
Vibration. So having these on this upper left-hand picture here, and you start to look at these resilient channels, that starts to play a pretty big role as well within the sound category. So your standard, say your two by four wall with our Safe and Sound product inside of there, what happens with that, the STC rating is a rate around a 37, 38. Then as you add these resilient channels, that bumps that up to an STC of 47 by having those disconnect of the frame, sheetrock to the frame. Now it's to these resilient channels or mass loaded vinyl, something like that. So when it comes to areas like mechanical rooms or maybe movie theaters, which it sounds like from conversations with Omar is becoming more and more popular down in your area. So having some, beefier assemblies in certain parts of the area perhaps makes quite a bit of sense. The other aspect to kind of think about is longevity. This picture on the left here, kind of in the middle actually, is going to be a pretty good example of how fiberglass over time performs. Over time, it likes to settle within the wall cavity. Now, this is because it has that lower density of material. Then as you move to your stone fibers, because of that extra density of material, it holds its shape much longer, giving you consistent quality year after year. With these big beautiful homes that everyone is building, having consistency year one is great. But if you can have consistency 10, 20, 30 years down the road, and you can kind of stand behind that, I think that's quite a powerful statement. We actually had some installation in Denmark that we recently had kind of taken out of an airplane hangar, and it had its shape today, or the same shape today as it did when it was manufactured over 50 years ago. So quite a remarkable longevity factor. And at the end of the day, it's because we don't have off gassing. There's no chemical reaction. We're just stone, and stone is just it's resilient, stands up, and holds its shape.
And just to interject there a little bit, Nick, especially for this group, it's also important to note that, as you're going into homes and you're testing things, right? If you were to take that thermal imaging camera and you were to look at any warm spots within a wall cavity, that those areas where that fiberglass has started to settle up at the tops, or let's say you have like, an older home and it has a rodent issue or something, and you could start seeing the separation where the rodents are digging through the fiberglass in the middle of the walls. Anywhere where you see heat transferring, that those are areas where sound is actually escaping. So that's another thing to think about.
Um, And then we're going to move into a little bit of the kind of sticking with this idea of longevity, looking at some of this long-term thermal performance or thermal resistance. As things ages, they don't always stay the same. R values perform the same way. What's nice about stone wool is, we hold that R value whether it's year one or year, 2 decades down the road. We don't decrease in R value. And again, that's just because we're simple material. There's no off gassing, there's no chemical reaction. Then you move into your polystyrene, extruded polystyrene, your XPS. Those over time could potentially lose some of its R value. So what we're really trying to show here is that even though initially there is a difference in R value, when you start to look at longevity and performance, we all actually perform within that same range. So no, even though initially there is a difference, over time, it doesn't really add up to much of a difference because of their slight drop in performance. I'm just going to skip those couple slides there. And then we're going to move into dimensional stability. Now, this isn't something that we really talk about, a lot about when it comes to insulation, because typically we've been cavity only insulation, whether it's wall cavity, whether it's roof cavity. But as we start to move into more and more of this exterior insulation, and I looking at the codes from where I am in Vermont all the way across the country, we are all kind of moving in this direction of, all right, how does that exterior, that split insulation look? How does it work? And more of the codes are starting to shift in this direction of, really wanting to see more exterior insulation. So as we move in this direction, expansion, contraction starts to play a larger role. Stone wool moves 1/10 of an inch over 33 feet, so a very small amount. Where when you start to look at your foams of the world, your extruded polystyrene can move up to 1.6 inches. Your polystyrene can move up to 2.4 inches. So you can get a lot more expansion contraction. Now, I was working on a project in Vermont where they had in the summertime built a house, installed XPS on the outside of the building. They had run out of money, so they put vinyl siding on it. We're a big wood market where we are in Vermont. So 10 years later, they came back in, take the vinyl siding off and to put wood siding on, and they came back in the winter. And what they had found is every single panel had shrunk an eighth to a quarter inch around each and every panel around the building. So what does that look like? Well, here's a kind of a good example of what that's doing. That's letting a lot of bypass or heat work its way through to the snow and melting that snow. Now, for us down in Texas, what that's really symbolizing is from the outside heat working its way into the house and causing the house to become warmer, as that temperature gets hotter and hotter outside. So that expansion contraction piece, when we're really trying to control, that outside temperature from working its way in, starts to play, a role within that equation of our wall design. Now, moving into water repellency, this is personally my favorite. I think water repellency is really what separates our product from a lot of the other ones that are competitions that are out there. But stone wool is hydrophobic, so it's treated for water repellency. Again, that oil-based binder, that mineral oil-based binder, resists that water from getting in. You can see the water that's sitting on here, and those water molecules are being resisted by the insulation because of that binder. Think of it like when you're at home and you're cooking. What happens when you put oil and water together, right? They repel away from one another. And that's essentially what you're seeing here. So as we get wet, we repel and keep that out of our fibers. We're unaffected by wet dry cycles. So if the product gets wet, it's not that the fibers themselves, just to clarify, doesn't get wet, necessarily, but the in between the fibers, the way we do is we trap heat energy in between our fibers, and in between the fibers, the water can kind of work its way through, and we become an effective drainage plant at that point. Um, so if our product does get wet within 24 to 48 hours, it can dry itself out really effectively. I was on I actually have a beaver dam above my house, and I recently just finished my basement, and it had flooded my house and my basement. We had 18 inches of water down there. And what I had found is when I went down there, I had to rip all the sheetrock out, throw it away, but I was actually able to reuse the Rockwell bats I had in there, let them dry for a couple days, fluff them back up, and I was able to reuse that material back into the wall assembly. So that shows you some of the flexibility that you have when you have material that dries very quickly, and doesn't have issues with mold or mildew within the system. So if you have to come back later on to do some work, you pull the bat out, you do some work, you put the bat back in. Very simple for repairs in the future. If you have a pipe that bursts, you can again take it out, fix the pipe, let it dry, put it back in. A lot more simple when it comes to things later on happening.
I like that slide before that. I hadn't thought of it in that respect. But looking at it from resistant to water, because we get a lot of questions about like the increased costs of insurance and replacement costs of insurance. And so your example of what you just said, let's say there was a fire in the house and maybe it was in the kitchen. Of course, a lot of the replacement cost becomes from the fire department having to spray the water in there to kill the fire that's now ruined the insulation that all has to be replaced. Do you know, would that be something that could save costs in replacement because it could be reused?
So I would say it depends. And what I mean by that is, even though the water from the hose itself is, yes, it can be replaced. There's more to this equation of a fire. What type of chemicals were burning in the fire, what type of other things cause that, and how much smoke is getting, embedded into these fibers. So you have to kind of look at the whole equation and say, can I actually physically reuse these or not? So in a fire, it's a little more, kind of wishy-washy in the idea of you have to really understand what's happening versus, say, a water issue with a plumbing or this or that. That's a much straighter approach because it's one thing you're kind of looking at, if that makes sense.
Sense. Yeah, that makes sense. And then there's two questions real quick in regards to that. One is, what's the lifespan of the water repellent? Do you know?
Honestly, off the top of my head, I don't know. This is actually the first time I've gotten asked that question, and it's a great question. I'd have to get back to you on that one.
Right.
We've been using Rockwell in my area for the last 30 plus years, and we still have yet to see any issues up in Vermont where our biggest issue is water and vapor. But it's something I can certainly get back to you on.
Okay, and then another one says, just as importantly, will the insurance company give discounts for using this type of insulation installed in new homes? Probably not.
Actually, I mean, I'm obviously don't work for the insurance company, but I do know that in certain places, um, you know, because we are non-combustible, that is, at least part of the equation of how you're getting, different insurances. For instance, in the high WUI areas, that is certainly some of the stuff that they are looking at. Now, I don't know to what extent or what that looks like, but I would certainly ask the question of could that help? It's because in some areas it kind of at least nudges them in certain movie areas in
It's one of
California.
those things, they just need to learn the benefit of it before they make an announcement for that. But
Mhm.
great. And then John asked real quick, is it flood resistant? And is similar to the FEMA approved, or do you know?
I mean, I don't know if it's FEMA approved. I know from my own experience, that 18 inches of water was in there for 4 days before I could finally get it all out. So it's after 4 days of being submerged, it dried out just fine and is still in my basement today. So from a personal experience, um, I haven't seen it. I've seen products with exterior insulation on the outside of homes for years, and it still looks beautiful and performs well. Again, I'm not saying that this is backed up by any documents, but just from my physical, seeing it, being part of those builds, some of the stuff that I've seen. But I would have to verify the whole FEMA part of it.
Cool. I think that's it on the questions right now. Thank you.
Alrighty. So now we're going to move into a little bit more of the vapor permeability and a little bit more of the building science part of the business, the AIA. So starting off, what is a good vapor open wall assembly? Um, Now this picture here, this unfortunately is a northern picture. If you guys see the class one or class two vapor barrier here on the inside, picture that being gone. This is not something that you're going to want to use in zone one, two, or three. Your vapor control does happen on the outside part of your sheathing. So please just kind of pretend like that doesn't exist there. So a good vapor open assembly, what we're really talking about is controlling the vapor flow with inside of our wall cavity. So if we can picture our wall cavity, a good vapor open system can both dry to the outside and can dry to the inside. On average, stone wool is 30 perms, so it has great drying potential. Now, what can control this is your vapor control layer. Now, for zone one, two, and three, that vapor control is going to happen out here at the sheathing location. So that's going to control this hot, moist air from working its way to the inside, where it's cool and dry, and we could potentially get some water, some moisture buildup in those areas. So we're going to have that vapor control layer out here. Oftentimes, one of the confusions that exists out there with these vapor open systems is this idea of vapor control layer and air control layer. Um, Now, air control is often the primary is out here sheathing. So just for some examples, something like Zip, where it's an all-in-one, where you're going to have your WRB which is going to be your bulk water management, your air control because we're going to tape the seams, and you're also using that as your vapor control to an extent on that outside as well with that material. So with those combination of materials, that's all formed here. But you can also have a secondary air control layer here, which is your sheetrock location. Now, it's important to note that we can have multiple air control, but we cannot have multiple vapor control. So we want the vapor control out here, but we do not want a secondary one in here, which sometimes gets a little bit mixed up in terminology. So with that, we now can allow for that vapor drying to the inside. When you start to, really look at some of these materials of these what you're using for WRBs, it still allows for some drying to the outside. So you have that drying potential to the outside. But it creates a nice air seal. And that's the key. Air moves 15 times more water than vapor diffusion. So if you have a hole here and you allow for air to pass through, well, it's bringing in a lot of water into that area. Where if we can make this plane nice and tight, well, now that diffusion or that vapor just kind of working its way through material is very, very small. So because it's very small, we can now allow this assembly in here to regulate naturally the way these houses are trying to ebb and flow throughout the year. So that's one of the important parts of a good vapor open system is having that ability to let that vapor ebb and flow as needed, but cutting it down out here in the sheathing and making sure we have our control layers installed correctly. A good vapor open system does not promote mold or mildew growth. Again, we have no food source within our side of our material, and it's really great for mixed climates. Texas is one of those places where you can go from zone 1 to 2 to 3 and all kinds of stuff within one state. So this is really great for those mixed areas.
Sometimes in the same day.
Yeah, right. Absolutely. So having this ability to really be able to handle those different swings is super important.
Yeah, we go from 1, 2, 3, and 4, and also A and B on all the above. So it's
Yeah.
just, it's nuts. Yes.
Yes, it's you guys have quite an animal down there when it comes to zoning, but no matter where you are, whether it's dry, whether it's moist, whether it's 1 to 3, and I think a little bit of 4 up on the upper part of it, you can really manage that moisture quite well. Now we're going to start talking a little bit about codes and this idea of exterior insulation. Now, why, this is just a hypothetical for everybody. Why do you think that exterior insulation is becoming more and more talked about and being pushed more and more by these codes? In my opinion, there are a couple different big reasons. First, thermal bridging. So no matter how much insulation we add with inside of our wall cavity here, we're still going to have a weak point within our frame. So, for instance, we're about 4 Rs per inch, where our wood is about 1 R per inch. So our insulation is 4 times more energy resistant than our wood frame itself. So whether it be our framing, our headers, our floor assemblies, or, wherever the wood is located, those are going to be weaker locations with inside that thermal envelope of our walls or our roof line. Now, by adding exterior insulation to the outside of that, well, now we're going to make more and more efficient buildings because now we have consistency of insulation over the insulation and over the frame, which is the really important part of that. So, no matter where you are within that building, it has insulation protecting that heat trying to work its way into the inside through those weaker points in the framing, making that system more energy efficient. So that's one of the big reasons. The other one is condensation. Um, so when it comes to condensation or the perfect wall assembly, there's basically ratios of interior insulation to exterior insulation that when you get these ratios correct, you can keep your condensation point on the outside of your WRB, keeping this inside nice and dry. Now for down in Texas, that minimum R value is going to be right around 5 on the outside when you have your standard mostly 2x4 wall down in Texas, where you have an R13 or an R15. And certainly code is looking at that R13 and 15 marker with that exterior insulation on that. So the reasoning for that is we're trying to get that moisture out of that assembly and kind of keep it out here where we can control it better. Because what do we notice out here? Well, there's no wood, right? There's nothing for it to mold, mildew. We talked earlier about we're a very effective drainage plane. So when water gets out here, it can drain through our product, get out of that assembly. Another thing to kind of think about when it comes to wood frame, um, is the cellular structure of wood the same today as it was building 20, 30, 40 years ago? Well, the answer is no. We're not necessarily building with old growth lumber, and now it's all fast growth lumber, so it's more acceptable to moisture. We're using more OSB than plywood, or even further back, we used to use wood boards on the outside, which can manage moisture much better. But now we have materials that do not manage moisture from the wood perspective quite as well. So by keeping our condensation out of our wall assembly and keeping it out here is going to keep the system dry, keep this draining, keep this nice and dry in the cavity, which is going to cause less issues as those buildings age. Um, Now, if you were to think about this from a foam perspective, one of the big issues, that we kind of run into is over time, the buildings kind of racked, As the buildings dry out, they shrink. The framing itself will shrink a little bit. Has potential to pull away from some of those foam areas. Maybe some of the foam starts to off gas and shrink a little bit then as well. So you start to get these areas around the frame that could potentially, see some connectivity to the outside shell, causing some moisture related issues. So no matter kind of what you do in this cavity, you still potentially could have some moisture related issues that can form right here on the inside of your sheathing or inside of your sheetrock on the inside. Where if you add that exterior insulation, you're really going to buffer that moisture that could potentially accumulate in here and keep it out here in this exterior insulation, keeping those systems much safer year after year, decade after decade.
Yeah, Nick, I like what you're saying about all that stuff. A lot of that stuff just drives home what we've been trying to preach for quite a while. But yeah, Texas kicking and screaming on trying to stay away from continuous insulation, which we know the power of it. We know why it's there. I've had webinars on that before. I mean, it just goes to show that it's important to have it. I understand the hotter we get down south, the more we're trying to keep cold air in, not cold air out. Yeah, I said that right. But yeah, it makes a lot of sense to do it that way. But we still have, Res Check and Ecotrope and Rim Rate can still build us a wall that's R13 with no continuous, and even up to climate zone 4. And that's getting harder and harder to do with the new code cycles that are coming out in the future.
Yeah, absolutely. And one thing that one of the biggest pushbacks we get is you're changing up our wall design or our sequencing, so our people installing it aren't as familiar with doing that style of system. One thing I would just throw out there is lean on us. Have conversations with us. We can get on calls. We can really work through a lot of those details, making those systems much easier to kind of digest and build. Kind of keeping some of that uncertainty maybe out of the equation so we can start using some of these different style assemblies. So we're there to partner up with you and your team. Uh, And the last thing I'm going to kind of add before we jump into some of these details is we do offer WFI analysis. So if you're ever looking to figure out, within this design that I'm building, within this zone, within this elevation, am I kind of at risk or am I reasonably in a good location to make a pretty durable wall assembly? So we have the WFI hydrothermal analysis that we offer. We do it for free. We do them every single week. It's something that I find super beneficial to kind of know where's my benchmark, where's my starting point, and kind of keep working your way from there. So just kind of a little throw out there just in case that is something that you're interested in. Now I'm gonna transition over to some of our details, and these are details that I do want to send to everyone because I think they're quite beneficial. This one we're starting off with our Rockwool acoustical catalog. Now, what this does is it goes through different SCC ratings, whether it's steel, whether it's wood, whether it's interior or exterior. So you can kind of gauge what is all this, what does it look like when I change different materials? How does that perform? I'm going to give you three quick examples of this. Just skipping the steel. I'm a big wood guy, so I like sticking with that. But we started off with what I'm going to call our standard wall, our master bedroom, master bath. Those 2x4 walls. With that, you can get an SCC of 38 by using our Safe and Sound or our Sound Bat products, which are 3-inch thickness, sheetrock on both sides, 2x4. I would say this is kind of your starting point where the nuisance noise from the other room is quieted. But if something happens, one of my kids fall, somebody's at the door, I can still kind of hear it, but it's tempered. Then as we start to move into some more higher performing assemblies, again, we add resilient channel. So this is the exact same wall, 2x4 AFB, 3 inches on center, or sorry, 3 inches thick. And all we do is add resilient channel. So by adding resilient channel, now we have an STC of 47. So maybe this is around your mechanical room, or maybe floor to floor. If you're doing multifamily, it's a great spot for that adjoining wall, to really help isolate sound from one unit to the other. But what about if you want to go to the Taj Mahal, where we're really talking great sound characteristics? Well, now we're going to be moving into the STC 60 realm, where we have a double-studded wall with a 1 inch air gap, with 2x4 on both sides, filled with our sound material. That's really going to up that game. Maybe you're doing a movie theater or a music area within the home, and you really just want absolute quiet. This is a great example of how we can kind of get there. Um, you know, Maybe you're doing some so this will kind of get you to that point. I would highly recommend just saving this document. So if you ever have any thoughts of, I'm just looking at different ways to get different sound characteristics, there's a great document that has it all kind of in one area. Um, let's see here. We have some really good testing for these WUI areas for 1 hour exterior rated wall assemblies. Keeping this idea of using exterior insulation for thermal is really great, but we can also use it to have great fire protection. So within this wall design here, where we have 1.5 inch of comfort board on the outside, and then we have whatever the makeup is between the siding, WRB and sheathing, and then you have a comfort batt material in the wall cavity. This is going to give you a 1 hour exterior wall. So if you're in those WUI areas, if you're building closer and closer together, this gives you a lot of flexibility within that fire safety category to help really, add that documentation to the way you're designing by making sure we're having these great non-combustible materials. It does walk your way down through the different materials and uses and what all that looks like. So not only is that going to give you great thermal, it's going to give you a great fire protection. And moving back to our sound, it also increases the sound characteristics of that wall assembly as well. We're going to go from an STC of 35 up to an STC of 39 on those exterior walls. So that exterior insulation is not just about thermal. There's a lot of really good characteristics that come by adding this to those designs, from sound to thermal to fire resistance to drainage plane, getting you just so much more stability within those wall designs. The last document I'm going to kind of walk our way through. We just came out with this document I guess maybe a month ago, maybe 2 months ago now. And this is our WUI exterior insulation details, where we talk about different things. We get into some of the different categories for states and what that all looks like. These are some of our fire rated designs, our 1 hour exterior insulation designs. Whether you're doing stucco like these two wall designs here, or maybe you're doing exterior horizontal siding. This gives you some options there. So just a really great document, again, to look at some of these details. It will actually go through what those details look like. So if you're adding that exterior insulation, it shows you how to detail those bottoms. So working our way from the outside in, we have our cladding. We have our strapping. Typically, that's a 3/4 inch strapping or airspace for our rain screen. Then we're going to have fasteners that connect back to our frame. We're going to have our 1.5 inch is a great thickness of comfort board that I highly recommend for your market, from our value to performance and from a cost standpoint. So a great option from there. Into your WRB, your plywood, and then your interior cavity insulation, so you can see all those different components. If you're doing some maybe some a little bit of this probably makes more sense, a little below grade work up against that stem wall, you can actually bring that insulation below grade, just like you see here. You can stucco over this portion, so it can be just as normal as your neighbor's house or their, the houses down the road. So it has that kind of stucco style finish down there. Um, let's see here. Again, these are details I'm going to send out to everyone, but it kind of just walks you through the different areas. Now we're kind of moving into those window areas and what that looks like. Um, I like to kind of go through it on this diagram here. But basically, with your windows, when it comes to exterior insulation, you have what's called an inning window or an outing window. And basically, what that means is where your window flange is located. So if you have an inning window, that's going to be located at your plywood plane, your WRB, that's all going to be conventional. Your interior will be conventional. We'll zoom in here. But now we're going to add this exterior extension jam to the trim to pull that out. Um, and that's going to be the same even in the brick side of things. I know you guys do quite a bit of brick down in your area. So we have different offerings for claddings. Let's see here. So even when you get to your brick area, you can see how the brick gets pulled out. You have your brick ties that tie back to your sheathing. But again, this extension jam here to make up for the depth of the insulation occurs in this as well. If you want to do an Audi window, basically you're going to block, picture putting a 2x4 around the opening, flashing back to your WRB, bring your insulation to that, and then your window flange will be pulled out to this location here. So now you're going to have a longer interior extension jam, but you're going to get rid of this exterior extension jam that you see right there. Sometimes it works really well, other times it does not. So it depends upon kind of design and what materials you're using. Also, when it comes to WUI area, ventilation becomes, more and more important to kind of look at, pay attention to. So this will actually go through by zone. So for climate zones 1 to 3, what those roof lines look like for different metal, for asphalt, what all that kind of looks like is from a makeup standpoint. If you're in zone 4 to 8, I know you have the upper part being 4. So that will give you some more of those correct control layers and where they're located within those designs, because the control layer on the roof for zone 1 to 3 is not the same control layer as it is in zone 4. It's located in a different location. Um, then you're going to get into the physical breakdown of what these look like, which, when it comes to WUI, ventilation and having the correct vents in those areas start to play a larger role. Things like Vulcan vent, brand vents, defense mesh. There's a bunch of different options that are out there. But depending upon where you are in your area, wall design, if you're up here at the ridge, or if you're down here at the base of the wall, each one of them have different components. So it's just a nice document to really walk you through the different steps and show you some of these different designs. That way, when you have questions, there's references to a lot of these items. Now, just to kind of, I see Randy, you pop it on. Did you have a question?
Yeah, just real quick, there is a question in the chat, which basically what we'll do is we send a survey out at the end of the webinar, and then they send the survey back, and that's how they get their certificate for ICC
Yep.
credits.
Yep.
We'll include these documents with that, if that's okay, because someone did put
Beautiful.
their email address in here and wanted a copy of this. So we'll send it to everyone through the survey.
Yeah, yep. I'll send it all to you, Randy, and then you can send them out, to everyone that it makes sense.
Thank
Um,
you.
Absolutely, we'll do that. But just to kind of recap on Rockwool, Rockwool is a really good, when it comes to building these equations of walls and roofs. Rockwool really does well for fire protection, both in WUI areas, in internal from room to room, around mechanical rooms. It does really great with sound control because of that, extra density material. It really stops that sound transfer. Great for thermal, again, versus today or 20, 30 years down the road. It's holding that longevity. It's unaffected by wet dry cycles when it comes to water. So if something gets wet, you can just take it out, fix it, put it back in. It's a very friendly product to use, easy to kind of work with. It just cuts with a serrated knife. Um, that exterior insulation is certainly something that is new for many states. It's not just your area, but many states. But as we move and we see the benefits of it, I think you're going to find that once you start using it, your customers are going to really enjoy that, and they're going to start to move in that direction, just like they have in Vermont, where I live, where it's mandatory now because so many people are using it. Omar, did you want to add anything before we kind of wrap up here?
Yeah. Well, Guadalupe did have a question. I saw on here. But how does it compare price wise with other types of insulation?
That's a great question.
Pandora's box.
Yep. So, well, I mean, so we'll start off by comparing it to fiberglass. So if you compare like our values together, like our value of fiberglass, like our value of rock wool, we're about 15% more. But we're going to get that great thermal benefit, and more importantly, we're going to get that moisture benefit. Fiberglass just doesn't kind of hold up quite as well, longevity from a moisture standpoint. So even though we are a little bit more, we offer quite a bit more benefit. Now, if you compare us to the foams of the world, I know that's kind of broken into two categories: vapor open or open cell versus closed cell. So I say open cell, we are cheaper than. Sorry, closed cell, we are cheaper than. Open cell, it's not something that I deal a lot with, so I'm not sure that comparison. Um, you know, um, so I hope that helps from a pricing standpoint.
Yeah, one thing I'll caution with that, and that's a great point. Open cell is gained a lot of traction in Texas, especially in the west side of Texas because it's a lot drier. They don't have to worry about high humidity issues. But I've been doing this for over a decade and know for a fact that there are installers out there of foam that, let's just say, they cut corners. They don't get like R value in the wall. They do nominally filled. They do shallow cavities. It looks pretty. It looks nice. You think it's a great product. I'm doing foam everywhere. It's fantastic. It air sealed everywhere, but you're just not getting that R value that you need. It will have problems in the house for comfort, and the sizing of the equipment's incorrect, and because they based it on an R13, and on and on and on. And I've dealt with Oklahoma in the past, and they see the changes because they're in climate zone 4. Well, 3 for the most of Oklahoma, but they want to get away from continuous insulation. And I understand why, because the builders aren't ready for this yet. However, you're stuck with either a high density fiberglass to get R15, which yours will also do R15 on a 3.5-inch cavity. But when you do open cell foam, it can only do 13. And so you're now having to do continuous, and they're trying to find a way to adopt the 2024 energy code by leaving the builders the opportunity to do R13 without continuous. It's just really hard unless you find a product that can do 15. And the only two that I know of is high density fiberglass or the stone wool products. So I like to see the stuff that you have there.
Yeah, absolutely. I appreciate that, Randy. And I totally, everything you said makes total sense. Uh, and just to kind of piggyback off one of the things you said, what's kind of nice about rock wool is, again, it's cut with a serrated knife. You can put it in, but because of the density of material, it makes you have to install it correctly because you can't just go over a wire. You have to physically cut for it and then slide it into that cavity, making the effectiveness of it much more effective. So it's harder to cut those corners, making it again, as designers, making it what we're kind of anticipating it to be, rather than being a little bit less than what we think it will be.
Yeah, we've talked to the end of the earth on the webinars here about grading of insulation, what third parties have to look for. And So I guess my question would be, since there is a little bit of difference in how it's installed to be correct, you guys, of course, I'm sure have training programs that any of your installers and your suppliers are trained the right way to do it. Because I don't know if it's true anymore, but all these guys used to get paid by the piece, and the faster they went, the more money they made in a day. They just compressed the heck out of it, and it destroyed the whole integrity of the insulation, which rock wool and stone wool products hold their shapes better, so I'm sure they're trained on how to do it correctly.
100%, and that's a huge part of what Omar's position is, being, in your area, is to get out there and help with the training and help with that support assembly. But it definitely makes him slow down. It's not a ton, but it makes him slow down enough to what that those details just they have to be done correctly, because otherwise you couldn't put your drywall onto those areas because it would bulge out unless it's done correctly. So it's kind of a once you see it, use it once, you're like, oh, that's exactly what I'm looking for. Boom, 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 boom. I'm moving on to the to the next building, so to speak.
So I guess too, on that end, when you said earlier about the 15% increase, I'm assuming some of that might be a little higher in installation costs due to the difference of the way it's installed.
Yeah. I mean, I think that's a fair statement. That you're going to find that, around electrical areas or plumbing areas like kitchens and bathrooms, it may slow you down a little. But I think on your normal areas, your bedrooms, things like that, I think you're going to find it's a pretty similar process. That your wire is 18 inches off the ground, making up numbers, but 18 inches off the ground. So you're going to bring a full back to the top of that, pull it up, and just cut 18-inch blocks and slide them in underneath the bottom. Which to me, being that we used a lot of my market up here in Vermont is heavily dominated by rock wool, and it doesn't seem to really affect us once we get used to how those systems work. We tend to install it quite quick.
Right. I mean, it's, yeah, yeah. It's just something I've always, if I've ever built or going to build a house on my own, it would be using the product, stone wool products for sure. And of course, Guadalupe does say it reminds him of HVAC ductboard, which is a lot more rigid, which is true. I mean, it looks similar to that. Doesn't have the full lining on it, but yeah, it looks similar to that. So I guess if you guys don't have anything else, I just wanted to follow up with just a couple of things. I mean, I've been in this business for over 10 years now. I learned a lot today just by your webinar. I appreciate Omar. He and I met in the Rio Grande Valley Builder Show. I appreciate you getting Nick involved. I experienced the torch that was there. I mean, I was freezing at that time during the show and used that to warm up my hands, but that's not what it's intended for. But it's a really cool way to show it. But I really didn't know, never thought about the expansion and contraction of foam board. I like that detail talked about. That brings up an aha moment to me of how aging buildings can, again, be a lot less than code because of the expansion, contraction, and issues they've had with products. You didn't mention it here, and I'm sure the answer is no, but that right now, currently, there's not a rock wool blown in product at all.
As of now, there is not a rock wool blown in product. It'd be great to have it in the future, obviously, but currently, it's not available.
Okay, and then the last thing I'll mention, in that first couple of slides, you mentioned like your water's recollected, but who uses that and where does it go after it's collected? Is it reused in the process or is
Yes.
Okay.
Yeah, yeah. So when you go to our factory, we have these big retention ponds, and all that. That's just all being reused in the factory. When it comes to like material that's not being to the right densities, we regranulate those, reuse it back into the system. We reuse the heat back into the system. So basically, everything that we use is in within that somewhere within that system of start to finish of the factory.
Did not realize you guys went to that extreme, and I applaud you guys for doing that. That's great. And again, I know why now. I used to be a lead green rater. I know why they'll certify your product as well and their product, and they'll get points towards their certification award on a building by using products like that. So,
And just to interject, Randy, real quick, I did drop in Nick's contact information as well as mine.
Yep.
You know, everyone on this call, you guys are the boots on the ground, so you guys see this stuff inside out every single day, and work work within the builder community. If you have any questions, if you would like to set up a call or a lunch and learn or whatever it is, with your organizations or with the people that you interact with out in the field, by all means, we consider Nick and I a resource, and we're here to support you. So by all means, reach out if you need anything.
Yeah, I like that R-Class Builder program. That's really cool. Did not know you guys had that.
Yep.
That's really neat. I guess there's a lot of training involved, a lot of the diagrams like we saw that'll be in those PDFs that we'll send everyone. So that's fantastic.
Absolutely. And that's another thing is I highly encourage everyone to join the R-Class Builder program. It's a Rockwell program that we have available for all of our builders and architects, and installers, where we hold these different webinars where we talk about, 1 week it's going to be on sound, and another week it's going to be about, insulating crawl spaces. Another one is going to be basements. And, we just kind of dig deep into the building science component of what it takes to build a great, long lasting home.
Great resources. Thanks, Omar. Appreciate that.
You got
So
it.
we'll wrap up real quick. Join us on our next webinar, July 22nd. It was not in my last newsletter, but it will drop in the July 15th newsletter just the week before. Basically, I just titled this From the Field, Real World Compliance and Enforcement. So basically, this session delivers boots on the ground perspective. I know I've done some in the past that I was walking around with a camera and filming it, and everyone liked those, but I just can't seem to get the recording of Zoom to work without being, as some people say, making them motion sickness. So it'll be a lot of pictures, a lot of field pictures we'll discuss and talk about. But we got some lessons learned from common violations that's stemming from document gaps. It's not just install mistakes. Third-party coordination is critical, but often overlooked. And then training and field resources make or break compliance. So we'll go through that on July 22nd. So I appreciate everybody being here. Thanks again. As we continue to support local officials, contractors, and any energy professionals across the region, we do invite you to stay connected with us. We're on LinkedIn. We're also on Blue Sky. And you can also visit directly at our website at eepartnership.org for any tools, training resources. NOAA has put together a legislative tracker that's now formalized, and he's got it to where the bills have come in and where they've sat, which ones were denied or not pushed forward. So I thank you guys again. Before I wrap up, I want to thank Omar and Nick. Thanks, guys, for doing this. I really do appreciate it. It was kind of a difference for us. We haven't really talked in depth on insulation products. So I appreciate you guys taking the time to do that. If you have any follow-up questions, be sure and email me. Their contact information was in the chat. You feel free to reach out to them directly. As I said earlier, we will add these PDFs that he's going to offer us and send it out with the survey, so you guys will all get copies of that. So again, thanks to everyone being on here, and you guys have a great 4th of July, and we will talk later in the month. Thank you.